In this lesson, students will be able to solve elapsed time problems to 5-minute intervals using an open number line. By this point, students should be comfortable partitioning number lines in a variety of intervals. In previous lessons, they also have had experience using open number lines with whole numbers. In relation to time, students can use number lines partitioned to the hour, half hour, and quarter hour to solve elapsed time problems. These skills are essential building blocks to today's lesson, and students will need to be proficient in each one to be successful in today's lesson. Let's look at our first problem. Ms. Kelly's class finishes recess at 10:15, but they don't go to lunch until 11:30. If Angelo comes into class right after recess and asks how much longer until lunch, how long would that be? Let's use an open number line to solve this and compare it to our clock. Just as we did before, we need to set our start time, which is 10:15. Our clock will reflect that time. Now let's leave some space to work with on the number line and mark our end time, which is 11:30. Now we'll use our demonstration clock to help us think it through and determine where the intervals will be on our number line. Let's start by moving the clock forward 15 minutes to 10:30, and I will reflect this on my number line. Let's move another 30 minutes. That would take us to 11 o'clock, and this is how I would mark it on my number line. Now let's move the clock forward 30 more minutes to 11:30 and reflect this on our number line. Our number line helps us organize our thought process as we think it through and helps us clearly see that it is 1 hour and 15 minutes until lunch. We want students to expand their thinking, so encourage them to solve this problem more than one way using an open number line. This time, let's move the clock forward 1 hour, which would be 11:15, and reflect this on the number line. Now we only need to move the clock forward 15 more minutes to reach the end time of 11:30, and our number line still shows 1 hour, 15 minutes until lunch. Try this problem. Field day games started at 1:45 and will last until 3:10 when popsicles will be handed out. Jake checked his watch at 2:35 and asked his teacher how much longer it would be until it was time for popsicles. How long does he have to wait? Remember, the first thing we do is set our clock to the start time and mark that on our number line. But what is the start time in this problem? Is it 1:45? Looking at the question being asked, we are looking at the time span from when the student checked his watch at 2:35 to 3:10. So 2:35 is actually our start time on our clock and number line. Then we will mark the end time of 3:10 on the number line. How could we solve this? What if we moved the clock forward 10 minutes to 2:45 and reflect that on our number line? Then let's move it ahead 15 more minutes to 3 o'clock and mark that. Finally, we could jump ahead 10 more minutes to get our end time of 3:10. Looking at the number line model, I can see it will be 35 minutes until popsicles are handed out. Is there another way to solve this? Let's start over and set our start time on the clock and number line and mark the end time on the number line. What if we moved the clock ahead 5 minutes to get to 2:40? Then we can move it ahead 10 minutes to 2:50, 10 more to 3 o'clock, and 10 more to reach the end time of 3:10. When added together, we still see it as 35 minutes. Solving the same problem in different ways on an open number line will help your child's understanding and confidence as they learn to see different possibilities and explain their reasoning. Our goal today was to solve elapsed time problems to 5-minute intervals using an open number line. We did this by using a clock to help us reason through the problem and a number line to organize and record our thinking. On each problem, we followed the pattern of first marking the start and end times and then determining efficient intervals to use.